All right. Good morning, everyone. This is Ankit. Let's continue with our session. People who have not joined will have to go through the session recording and they can let me know later if they have any questions. Okay, so we will follow the same process. If you have any doubt, you can just unmute the mic and ask me the question if that is really urgent. Otherwise, feel free to put it in the chat. Your responses also, I would appreciate if you can put it in the chat. Subhalakshmi, I know in the last session you were not present. I hope you went through the session recording and you have looked at the concepts of the pillars of hoops. So today class, we will be continuing with one concept that I wanted to take in the last session, but I could not. Let me say that concept is that of import. So in the last section, we would have imported something called as ABC. That is the abstract class package. And we would have from the abstract class package, we would have imported something called as capital ABC, which was the abstract class. And we had the abstract method. Now, after that, we looked at one more concept, which was the place where we looked at the scope of the variable. And I would have mentioned that if you create a protected variable, any user who wants to import your class will not be able to access that particular variable. Now let's understand the concept of importing a little bit more in detail. I'll just take 2 or 3 minutes and then we will. This is something which is rather for your understanding purpose. So you need not do it. I just want you to pay attention so you can understand what is going on, because based on the IDE on which you're working, there are different ways of achieving this. But when you do the project, this is something which we will do extensively. So we know that there are certain packages, there are certain classes and functions that come by default installed in your Python. So let me show you one such package. There's a package called as math package. There's a package called as ABC. We have packages Numpy, Pandas, which are installed when you install your Python. That means these packages are already available in the form of a .py file inside your system, but they are not available in your session. So if you want to use these packages into your session, you will have to use a word import and tell Python that I want to import a particular library, a particular package. Right, so let's say today we are going to start with Numpy. So Numpy is a package, it's a library which will have a lot of classes, a lot of functions, and you will import Numpy. Sometimes what happens, classes, you will have a lot of functions and lot of classes, and you do not want to load the entire package. You don't want to load the entire py file. So what you say, you go to that py file, you go to that package and say, for example, from ABC import capital ABC. Okay. So this is how you import a package, or this is how you import a particular class from a package. Every time I use the word package, it means it's a .py file. Now we also have an option of creating our own packages, of creating our own .py file. So let me today create one py file. What I'm going to do is I'm going to write down a function. I'm going to write down 4 functions. I'm going to say addition. It takes as input 2 parameters, num1, num2, and it will return num1 plus num2. Similar to this, in the same cell, I'm going to simply write down 4 functions. The second function, I think we would have all written down these functions. I'm just going to quickly make a note of this. Subtraction, and this function will subtract the 2 numbers. Then we have multiply. This function will multiply the 2 numbers that you have given as input. And finally, we have divide. Divide will divide the 2 numbers. And what I'm going to do, classes, what I'm going to do is I am now going to save this file as a py file. Let me download in your Jupyter notebooks. You can download one IPynb file as a py file. I can go to download as and save it as py. It was going to ask me for a particular name, and then I'll show you that I have saved it as a .py file. Let it open. I'm going to save it as arithmetics.py, for example. Okay. Now, the moment I save it, you will see, let it get saved. You will see that I have this one additional file. So this is the untitled PYNB. I'm now going to close this file because I don't want to use it anymore. And I'm going to open this untitled. Let me remove it completely from the memory so that it gets deleted. And we can open the arithmetic.py. Now, the moment you see arithmetic.py, it's not a normal Jupyter notebook. You see, it has added some comments. This is a Python file. I have created a package called as arithmetic. It has 4 functions: addition, subtraction, multiply, and division. What I'm going to do is let me go to my OOPS notebook. Let me go to my OOPS. So let me tell you again what I have done is I can see you can do this by simply opening a notepad, writing down these functions and saving it as a .py file. You can open any IDE. You can do it in Visual Studio. You can do it in your Jupyter notebooks, Databricks notebooks, Google Colab notebooks. The moment you say notebook, what it does is it will save with an extension of IPYNB. It's the Python notebook. If you see, all these notebooks are IPYNB. Our control structures notebook, our Python basics, inbuilt data structures. Then we have OOPS and so on, right? So if I want to create a package, what I need to do is create a .py file. So .py is nothing but a Python file. IPYNB is nothing but a Python notebook. What I need is a Python file. So I can write down some classes. I can write down any code inside my Python notebook, and I can save it as a py file. So this Python file contains 4 functions: addition, subtraction, multiply, and division. Now what I'm going to do here is I am going to import this particular file. See, if I do this right now, addition, and I send 3,4, you will see that it will return an error saying addition is not defined. We do not know what addition is, right? I want to say then, okay, go to the file arithmetic and then get me addition. It will still throw me an error. Why? Because you have created a package, but this package is currently not loaded inside your current session. Now, what I'm going to do, I'm going to first start with import, let me say arithmetic. The moment I do this, Python goes inside the .py files and loads this arithmetic file into the current session. So now what has happened is these 4 functions have been loaded into your memory. And now if you say arithmetic dot addition and pass any 2 numbers, let's say 3, 5, it will give you the result back. So this is the package, which is the .py file. This is the function that you have called or you have invoked. Because of the import statement, you can load any package which is a .py file into your current session, and you can then use the functions or any class that is defined inside that arithmetic function. So let me do one more thing before I move ahead. You would have seen that I have used a concept wherein I said from. Okay, let me do it here itself rather instead of doing it here. What I can do is I can say from this file arithmetic. See, every time I use arithmetic.addition, it becomes slightly difficult for all the developers to write it again and again. So what I can do is I can simply say arithmetic from this arithmetic, that is from the file arithmetic.py. I just want to import one function. I don't want all the functions. I want to import, let's say, subtraction. Okay, and then what I can do is I don't have to then mention arithmetic.subtraction again and again. I can simply use subtraction and pass 2 values 8, 1, and it will return the value 7. Now, if I do, but see, if I do addition 4, 5, it will still throw an error saying addition is not defined, because from arithmetic package, I have only imported one function, which is subtraction. So this is how the import works. If you have a custom file that you have created, you can import it into the current session in order to use any functions or class which are present inside these particular files. Otherwise, if you want to use an inbuilt file, there are a lot of packages that Python comes with. I'll tell you, there are for each and everything, there's a package. Today, we are going to start immediately after this, we are going to start with Numpy, which is used for numerical operations. Our next session would be then based on pandas, which is used to read tabular data. Then we'll go into visualization where we will look at matplotlib, we'll look at some seaborn functions and all. Then once you move on to statistics, you will see that you have packages such as stats, you have statistics packages, you have a lot of packages, you have scikit-learn for machine learning. As and when you go, you will see a lot of packages are already inbuilt. But if you want to build some package, if you want to create some package, Python being an open source language, you can do it. You can do it for your own project. You want to create a new package so that you can do it in some You can also contribute to the actual Python repository as well. It's up to you. So import means what? Import any package inbuilt or custom into your current session so that you can use the functionalities that is the class or functions which are written inside that particular package. Okay, so this is the concept of import. With that, what we will do is I hope the concept is clear. What is the meaning of import? Why do we do it? How can we import an inbuilt or how can we import a custom file? If we are clear, what we are going to do is today we are going to start with Numpy. Let me say C07 for you, for your batch. Let me know if you have any questions, any doubts, anything with respect to import, we can do that. But if no, we can then go ahead and start with our scheduled topic, which is Numpy. Okay. Cool. So I would request, Subha, I think you are the only student today. So I would request you to open a new notebook. We can start with our Numpy packages. Numpy is a package, and people, I know a lot of you would be watching this recording in future. So if you have any questions, I would suggest that you go with the same speed, you go with the same pace. All the codes that we are using, you can use the same codes. If you're using Collab, Subhalakshmi, that's fine. You can open a new notebook even in Collab. See, in Collab, I would suggest that let's not do import and create our own file. If you want to do, you can still do that. That's not a challenge. You can create a file, you can upload that .py file, and you can exactly replicate what we did. But for Numpy, if you are starting with Numpy, you can simply open a new notebook and it will be automatically saved. You try to import, you want to do that? Okay, let's do that. Okay, let's do that. Okay. Can you share your screen? Let's see, since you and me are only here, let's share your screen and see what is going on. There will be a small green button at the bottom center of your screen. Okay. So Lakshmi, can you see a small green button at the center of your screen? You can use that, and then you will have to select the entire window that you want to share. Your screen is loading. Has started sharing screen, but I cannot still see your screen. So I think and yeah, it's visible. Can you go to your can you go to the Google Colab, the next tab? Okay, Subha, I think there is some issue in the. Okay, let me do one thing. Can I do it in Google Colab for you? Would that help? I think there is a bandwidth issue, so you are not able to share properly. Will that work? Shall I do it in Google Colab once for you? So, Subha, I think you have rejoined again. I wanted to check with you. Shall I do it in Google Colab once for you?
Yes, Sangeet, am I audible?
Yeah, you're okay.
I have network issue. My collab is not loading.
Okay, no worries. So let me do one thing. Let me.
One minute. I'll try to share one more.
You want to share? Okay, let's go.
Yes.
Let's go. And yeah, it's loaded. Right. So let's see your arithmetic.py file. So it's opening up. Cool.
I have network issue. So
No
you
worries.
please show me how to do this.
No worries. Let it take time.
See, I tried here addition. My old practice book.
Okay. So do one thing. Do one thing. Uh,
Yeah.
can you open a text notepad or a text? See, what we need to do is we need to add another file. First, we will have to create your own package, right? So what I'll do is, let me say,
Yes.
let's create another function. Let me see if I can download it or not. In the same Google Colab, let me see if we can do it through Google Colab or not. What we need.
Okay, Ankit, you do in your collab, then I can understand how you're doing.
Okay, let me then share my screen. I'll
Yeah.
do it. Okay.
Yes.
So let's go here. Let me also see. See, this is my arithmetic PY. Let me open the Google Colab. Seems to have hanged. I think there is some Zoom issue today. Give it a second, it should be back. Even my browser is hanged. So let me open Google Colab. Let's go to Google Colab. So see, when we are trying to import, right? The concept of import comes when you have your functions or your classes written in a different package. Okay. So let me open an untitled file. Excuse me. Give me 1 second, class. Okay, so let me open a new notebook altogether. And what we will do here is where I will import. Okay. So
Yes, Sangeet, like this only, I opened one more notebook and I created that all those arithmetic functions and I saved that file.
you have to save it as .py, not
Yes.
as .py. So see, I'll tell you why I'm saying that. Once you do this, let's say return num1 plus num2, what will happen is, but you can't change this as py. Do it make it as arithmetic.py. Okay, and the moment you save it, let's say it will automatically say, I have pressed Control S. Okay, now what I want to do is, if I go here into my untitled notebook or any notebook, I first have to import arithmetic. But if you see, if I execute this code,
I am not able to see your screen.
you're not able to
Still it
see my
is in arrays, NP arrays, two-dimensional array.
two-dimensional arrays. Okay, let me see. Reshare the screen. Is this visible now? It's T numpy. Is this visible now?
Yes, yes.
Okay. So see, what I did is this was a notebook. It had untitled.ipynb. I created .py here. Okay. First of all, I changed the name of the file to arithmetic.py. Then I went here. What you need to do is you will have to upload here your arithmetic.py. Until unless you upload here, you won't be able to use. So what you will have to do, you will have to download this. So do one thing, download this, download the py. It will download. Okay, so let's do one thing. Let's name it as arithmetic. Let it be named as arithmetic. Let me download this. Download the py file. It should download as arithmetic.py. So I will save it anywhere. I'm going to save it in my downloads. And you can call it as arithmetic.py. That is fine. It should be .py. That's it. Once you do that, you will have to come here, upload it. So let me go to untitled. Let me to uploads. Let me go to downloads. Still downloading. Give it a second. The internet today is really slow. Still downloading. Okay. Let's see. Has it downloaded? Not downloaded. What is the issue? Let's download again. Download the py file. Oh, okay. So once we download, what we can do is we can go here. We will have to upload here. Okay. So what we have to do is we have to upload here. Once you upload here, and then execute import arithmetic, now it will execute. Do you see now we don't get an error. After this, you can simply say arithmetic dot addition and send, let's say 3, 4. It will return the result such as 7. So let me repeat the steps. So what you will do, you will save a file as arithmetic. You will have to download this file. Go to files, download it as download.py. Why? Because wherever you want, Google Colab has this issue. See, every time, and I think in Pandas we will cover this, that every time you want to use an external file in Google Colab, you will have to first upload it into your datasets. So where is your dataset? If you come to the left-hand side of your Google Colab, go to the folder structure. You will find this particular structure. Arithmetic py is what I have added. Go to this option, upload to the session storage. So what will happen is this file will be uploaded to your current session. Because Google Colab does not have access. This is something which saves your files in the drive, and it will not use the drive directly to install your packages. So what you do is you upload your package here, arithmetic.py. This is only for your custom files. Once you upload it here, it becomes available to the session. Then you can use your import statement and follow the same process. Do you want to try this out? So by internet, if you want to try this out? Yes. Then let's try it.
Done, Ankit. Hello.
Yes, Shubhalakshmi, tell me.
Yeah, yeah, completed. I got result also.
You got result, but you got the
Yes,
idea how to do it, right?
yes.
So see, so I would always say this in all my classes. You will get result because I am here, right? I'll help you to get the result. But did you understand the concept? That is more important, right? So,
Yes, understood. Thank you.
great, great. Okay. Then let me go back to our Jupyter notebook where, okay, I deleted all the codes. Cool. So now let's do one thing. Let's open up a new Jupyter notebook. Trilesh, you also let me know if you have any questions, if you have any doubts. Okay, let's quickly open up a Jupyter notebook if you do not have anything, and then we will start with something called as Numpy. Now, Numpy is a package which comes pre-installed in your Python. It's a package which is used to perform numerical operations. If you break Numpy, it appears like numerical Python. But I would stress it multiple times throughout the session of Numpy that Numpy is a package which is used to perform numerical operations. Okay, so I am going to first import my Numpy, and I'll tell you why I keep stressing that it is used to perform numerical operations. Because a lot of students I've seen, they get confused, assuming that NumPy is used to create arrays and perform operations on arrays. No, NumPy is a package which is used to perform numerical operations. It can perform these operations on integers, decimal points, any numerical data. And array is an added advantage that we have in case of a NumPy package. What are these arrays? Why are these important? How to use them is what we have planned for the entire session today. Now, what the first thing that we need to do is we need to import NumPy into our current package. So since this is a pre-installed package, so people are using in Google Colab, they can directly import NumPy because this is something which comes along with Python. And I'm going to use an alias called as NP. Now, what is an alias? Alias is a word that I'm going to use instead of NumPy. See, if you look at this arithmetic dot addition, what I've done is I have to use the name of my package and then access the different functions. Similarly, in NumPy, when I'm going to use the NumPy functions, every time I will have to say NumPy dot NumPy dot NumPy dot. So instead of saying NumPy, what I'm going to do is I'm going to use NP. This concept wherein you are going to call a particular package as a different name is called as aliasing. And this aliasing can be done with the help of a keyword called as. This simply means that you're telling Python that in future throughout this session, I'm going to use NP instead of NumPy. So it's like an alias name. It's like a short name or a pet name. In very simple terms, it's like a pet name that you're going to say. But whenever you say NP, you are actually referring to NumPy. So people who are importing this package for the very first time, right? For the very first time, it will directly get installed and it will be available in your session because it's already installed in the Python repositories. It will take some time for you to install. So let me comment out this for you as well. Import NumPy package with alias NP. So let me repeat, Numpy is a package which is used for numerical operations within Python. It has a lot of functions, a lot of classes to perform various simple to complex operations within Python. All these operations are mathematical operations, numerical operations. I'm going to import this package, and in the entire session, I'm going to refer to this package as an alias name, as a new name, and that name is going to be NP. Now, people, don't worry. This NP, you can give anything. The alias name is up to you. You want to give it as A, you can give it as A. You want to give it as B, you can give it as B. However, I would say that NP is something which is an established and an unsaid rule among all the Python developers across the globe, that the aliasing for NumPy is going to be NP. Okay, if you open up any book, if you open up any tutorial on NumPy, even the official documentation of NumPy, which is available on the internet, you will see that everyone uses the alias as NP. So anytime you see NP dot, people know that you're talking about NumPy. However, this is not a strict rule. Aliasing is up to you. You can give any alias name that you want. However, again, I would recommend that since every Python developer out there uses NP, use NP so that if anyone else sees your code, it's very easy for them to understand as well. Now, before I go ahead, what I want to do is, I want to quickly take you through some theory. Let the whiteboard load. Okay. Now see, NumPy comes with one specific data type, and that data type is called as array. I don't think the pen is working. Let me see. Yes, it's working. Okay, so we have a specific data type. Class, we would have seen a few data types and inbuilt data type which are available within Python, such as list, tuple, right? Do you remember, class? List, tuple, strings, sets, dictionary is something which we would have seen in the past, right? Now we have one more additional data type which is available, and this data type is called as array. Now, before I move ahead on the concept of array, let's go back a little bit and understand what was list. If you remember, while studying list, I would have said that a list can contain any element of any data type, right? It can contain a string, it can contain a number, and it can contain different elements of multiple data types. This is a list. However, the difference between a list and an array is that array will always contain elements of the same data type. I can have all strings, I can have all numbers, I can have all floating point numbers, I can have all Boolean values, any inbuilt data type that I know of. But the only thing here is, in an array, you should have all elements with the same data type. So list can have elements with multiple data types. Array is an object that will have multiple elements, but all the elements are supposed to be of the same type. That means within this array, you can have all numbers or all strings, or if you want, you can have all numerical values, all integer values, all floating point values, all Boolean values, but they should be same. You can have here true, false, but then they should all be same. Now, for the session today, we are going to be focused on an array where all our elements are of the numerical data type. Now, in case of an array, the NumPy package gives you a function called as array, with the help of which you can create a different arrays. We will see, we will be creating a lot of arrays today. Okay. So the NumPy package comes with a function called as array, which is used to create different types of arrays. Now, when we talk about arrays, there are two. Now, this is very simple school maths. I think every one of us would have done this in our school days. So I'm going to quickly revise. We have two types of arrays. And since we live in a three-dimensional world, we are going to focus on two types of arrays. The first array is a one-dimensional array, and the second is a two-dimensional array. Now, what is a one-dimensional array? One-dimensional array is an array which has only one row or one column. Okay, also known as vector. So let me quickly, the one-dimensional array, also known as vectors in linear algebra. You will go through linear algebra in your future sessions. But vectors means that you have only either one row. I can say that 1, 2, 3. I have 3 rows here and 1 column. Can you see? Or if I say 4, 5, 6. 4, 5, and 6. What is this? This is again another array, but here I have 3 columns and 1 row. Now, I know a lot of you might be confused about what a row is, what a column is. So let me just revise for you quickly. This is called as a row, and this is called as a column. Similarly, if you talk about 4, 5, 6, you will see that I will say that this is a row and these are my 3 columns. So what is row? The data when stored in your horizontal format is called as a row. If you look at any table, right, the same concept applies even on arrays. In tables, you have rows and columns. What are rows? Rows are the horizontal lines. Both columns are your vertical lines. Similar to that, in arrays, you will have horizontal lines, which will be called as rows, and vertical lines, which will be called as a column, right? So if you see, if I let me call this array 1, 2, 3 as an array A. Can you tell me how many rows are present in this particular array? Can someone tell me how many rows are present in this particular array? I want to know the number of rows and columns. I can say I have 3 rows and 1 column. I have 3 rows and 1 column. Do you all agree with this? Yes, no? And if I say this is my array B, what is this? This has only 1 row and 3 columns. So I have 1 row and 3 columns. What I'm trying to say is if you have either the number of rows as 1 or the number of columns as 1, you call such an array as a one-dimensional array. Why? Because if you see, the array is expanding only in 1 dimension. If you plot this on an XY axis, either you're going towards X or you're going towards Y, but you are only expanding yourself in 1 dimension. The second dimension here is just present because there are some numbers present. So if I say that I have 1 row or 1 column, I generally call it as a one-dimensional array. Now, I think a clarity would come up when we look at a two-dimensional array. So let me quickly go and create a two-dimensional array. What is a two-dimensional array? When you have more than 1 row and 1 column. So let me say 1, 2, 3, 4, 5, 6, 7, 8, 9. And let me say 10, 11, 12. Okay. Now this is an array that I have created. I'm going to encapsulate in square brackets. I think in school you would have studied this in the name of matrices. I think in school you would have studied this under the topic called as matrices, matrix addition, subtraction. Then you would have had matrix multiplication, which was a very complex. Then inverse. Some memory gets jogged in because you would have obviously studied this adjugate, inverses, identity matrix. So all these are matrices. In programming language, we are going to call it as a two-dimensional array. Now, can someone tell me how many rows are present in this particular array? Can someone tell me how many rows are present in this array? Anyone? In the chat? No one? How many rows are present inside this particular array? Okay, so let me tell you. See, if you see, you can see that there are 4 rows which are present. Row 1, row 2, row 3, and row 4. Yes. So I have number of rows which are present are 4. And how many columns are present? We have 3 columns. So 4, 3 is called as the, correct, that's right, is called as the dimensions of this particular matrix or this particular array. We are going to say this is a two-dimensional array. Why? Because both our rows and columns are more than 1. So if I create 10, 11, 12, 11, 12, 13, an array like this, which has 3 rows, but it has only one column. Or if I create another array, let me say 20, 21, and 22, which again has only one row and three columns. What do you see? These are called as your one-dimensional arrays. But whenever you have more than one row and one column, you call them that these are the two-dimensional arrays. A lot of times, this 4-3 is called as the shape of the array. What is the shape of the array? Now, if you come to know about the number of rows followed by the number of columns, if you look at the number of rows followed by the number of columns, that is called as the shape of your array. Number of rows, comma, number of columns. If you look at this, this is called as the shape of your array. So quickly class, this is shape 4-3, this is shape 1-3, this is shape 3-1. Right? A two-dimensional array has more than one row and column. A one-dimensional array will have either one row or will have one column. Okay. So generally in Python, if you see your one-dimensional rows are stored like this, wherein if you create a number 1, 2, 3, they will store it in 3 rows and 1 column. And in 2-dimension, you can determine what are the rows and what are the columns. Now going back to the concept of indexing, you would have seen what indexing is during list and strings and our basic data types. Here as well, I'm going to say one thing, that your indexing always starts with 0. So your first row will be called as row 0, row 1, row 2, and row 3. The indexing in Python always starts with 0. Similarly, this is column 0, column 1, and column 2. Now let's quickly play a game to understand how to access each and every element. Okay, so if I'm going to say this is 0, this is 0. If I want to access my element 1, how can I access it? Let me call this matrix as A, capital A. If this is my capital A matrix, I can access the element by using a two indexing notation, wherein my first index, the first square bracket or the first index indicates my row index. It will indicate my row index. And my second index will indicate the column index. So what I'm trying to access here is, I'm actually trying to say that I want to access the element which is present in my array A at index location, row index 0 and column index 0. At row index 0 and column index 0. So it will give me the value of 1. So now can someone tell me, if I want to get the value 8, how will I write down? What will be my row and column index? A. Fill in the blanks, class. What will I have if I want to access 8? What is the row index and column index that I'm going to give? If I want to access the element 8, I will have to give 2 column index. I have to give 2 indexes. One is the row index, one is the column index. What will be the row index and column index if I want to access the element 8? Anyone? Anyone wants to know? You can unmute and let me know as well. If you're unable to put to chat, you can unmute yourself and let me know as well, so that I understand that you have understood the concept. No one? Okay, so let me tell you. If I want to get the element 8, what is the combination I need? I need the combination of row index and column index, right? I need the combination of row index and column index. So what if I want to access the element 8, I am going to say a column row index 2, column index 1 will give me the element 8. Does that make sense? Yes. Yes, class. So based on the row index and column index, we will go through this once again. Do not worry, we will go through this once again. But based on the row index and the column index, you can access the element that you want, right? You will have to give the index of the row, you have to give the index of the column, and always remember that the indexing starts with 0. So now let's do one thing. What we will do is, class, we will go back to our notebook and let us create a one-dimensional and a two-dimensional array. The screen load. So what we are going to do, we are going to create our first one-dimensional array. Okay, and I'm going to break one rule. Today I'm going to use A, B, C, D, E, F as the name of the variables. I generally do not do that, but today only for the purpose of studying, as we are going to create multiple arrays and we are theoretically creating numerical arrays, I'm going to use the variables A, B, C, D, E. So in order to create an array, the array object as discussed previously is present inside my NumPy object. And I'm going to use the function called as array. Now, please note class that this function takes as input a list. It will take one single list. So if I say 1, 2, 3, which is a list of 3 numbers, it will create a one-dimensional array of 1, 2, and 3. Let's do that. Let's print A, and you will see that it has created 1, 2, 3. Every time we create a new object, what do? We first check what is the type. If you see the type, it will say that NP ND array. ND array here stands for n-dimensional array. It means that you're trying to create a dimensional array. It can be 1D, it can be 2D. The same function is used to create one-dimensional and two-dimensional arrays. And you will see that numpy.nd array is the type of the variable A. Let me repeat. You can create an array with the help of a function array. np.array takes as input a list of numbers, one single list of numbers. You cannot give multiple lists. You will always give one single list of numbers. Okay. The moment you give this list of number, Python will store it as a numpy.nd array. Similar to this one-dimensional array, we can also create a two-dimensional array. And in order to create a two-dimensional array, again, same function is what we are going to use. But I want you to pay attention on how do we create a two-dimensional array. See, I mentioned that it's only going to take as input one list of numbers. It's only going to take as input one list of numbers. But whenever we want to create two-dimensional arrays, within that list, we are going to provide two different lists. So in the first list, I'm going to give the first row. In the second list, I'm going to give the second row. And if you want to give the third row, you will create third list. So what happens is you end up giving two square brackets. But technically speaking, it is a single list which contains two elements. Those two elements themselves are lists. So every row is represented as an internal list within the outside list. Now, if I print B, you will see that I have printed a two-dimensional array where my first row is 1, 2, 3 and my second row is 4, 5, 6. If you check the type of B, again, you will get the same thing, type B, and you will see you are getting a NumPy array. Okay, so what we have seen, how to create a one-dimensional array and a two-dimensional array in Python. In order to create these arrays, you need to use a function from NumPy, which is called as array itself. The beauty of Python is Python has most of the functions with the same name, self-explanatory names. This function np.array takes as input a list of numbers. Now, the same function can be used to create a one-dimensional array or a two-dimensional array. What is a one-dimensional array? Where you either have one row or one column. It's a straight list of numbers. What is a two-dimensional array? When you have more than one row and column, right? Something like this, 1, 2, 3, 4, 5, 6. Okay. Now, in order to create a one-dimensional array, you can pass a single list of numbers. Python or NumPy will convert that single list of numbers into a NumPy array, a one-dimensional array. When you want to create a two-dimensional array, within the list, right? Within the list, you will pass two lists. Each list will represent one row. So let's say if you want to pass 10 rows, that means in the outside list or in the outer list, you will pass 10 lists or 10 different combinations of lists so that each list will be treated as a row. Python will understand, okay, the first list is the first row, the second list is the second row. And we are going to look at a property that will help you understand, okay, Python does really understand that 1, 2, 3, since you have provided the first element inside this, it should be an error. Also note that always have your dimensions fixed. Like see, in one-dimensional array, it does not matter. You can create any amount of elements. You can enter any number of elements inside your list because it's a one-dimensional list. It's a straight list. It's actually a list, right? but since it has all the elements of the same type, you will be able to create a one-dimensional array. In case of a two-dimensional array, as we were discussing, that each list will be treated as a single row. That means that each internal list should have the same number of elements. If you give different number of elements, if you give anything like this, see, it will obviously return into an error. So always see to it that you give the same number of elements in the internal list, because here you are saying that I want to create an array with 2 rows and 3 columns, right? This is each list will be treated as a single row. So in the same row, you should have the same number of elements. Let's quickly try this out, class. Let's quickly try this out.
Yeah, hi Ankit. Sorry, actually I joined a bit late. Uh, Before Numpy, are you discussed about pandas or any other stuff?
No, so Vinay, right?
Yeah.
We are discussing NumPy. So the moment I think you joined, we were discussing one-dimensional and two-dimensional arrays.
Yes.
Before that, we had discussed something called as how to import, what does actually import to, how can we import custom files, or how can we create custom packages into our, our old folder structure. That was one part which was discussed. You can go through the session recording. I have explained it in such a detail that even if someone watches the session recording, they should be able to understand. I think recently I see 4 or 5 of you joined. That is when we started with this new package, which is called as NumPy. It's a numerical package or a package used for numerical operations. Okay, you can import it as an alias and see, I will keep mentioning this again and again. Although this package is majorly used to create one more type of object called as array and perform a lot of operations on the array, any kind of numerical operation that you want to perform can be performed by using this package. So we have just imported the package, created 2 objects, one-dimensional array and a two-dimensional array. That's it.
Yeah. Thank you.
And class, do let me know if you are clear with what I see. This was something which, as I mentioned, in the name of matrices, you would have studied in your school as well. So do not worry if you don't understand. Let me know in the chat or let me know by unmuting yourself that you are still confused about anything, and we can retake that topic because it will be a revision for a lot of you. And if you are done and you have understood well, let me know that as well, so that what I can do is I can give you a new property to check. All right, let me know once you're done, class. Let me know once you're done. If you are done, I'll give you something to do, people who are done. I want you to check the shape with the help of a property called a shape and let me know what you think it does. We have already discussed what a shape is. We have already discussed what a shape is. So if you check the shape, you will see that you have the number of rows and number of columns. So if you remember, I was saying that Python will or NumPy will automatically understand that 1, 2, 3 is your first row, which is the inner list. Then the second list is your second row. So it has identified that you have passed 2 rows. If you see, these are the 2 rows and the 3 columns, and it will give you the shape in the form of 2 rows and 2 columns. Similarly, you can also check b dot, let me say, there is one more property called as size. This property, tell me what do you think it does?
Number of elements.
That's perfect. Yes. Size will give you the total number of elements. Do you want to try out the shape and size for a one-dimensional array as well? Try it out for A as well. In fact, when you try out the shape property, it's a property here class, it's not a function, so you will not be using any round brackets or parentheses after that. You will see that it has given 3 comma nothing. So this nothing means that this is a one-dimensional array that has just 1 column and it has 3 rows. Similarly, a dot size will give you the total number of elements for a one-dimensional array, which will be exactly equal to your shape or the number of rows.
Like Ankit, how about a three-dimensional one? Like uh, how it will show?
So, okay, so this is a question that I get almost in every class. How can we visualize a three-dimensional array? Now, since our screens are only two-dimensional, right? All our screens are two-dimensional, so three-dimensional visualization would be slightly difficult. But if you keep giving list within a list, okay, if you keep giving list within a list, you will keep increasing the number of dimensions of your array. So for a 3D array, what you will have to do is within the same list, you will have to give one more list. Right. So if I have to give you an example, this is very difficult to visualize because most of our screens, they work in 2 dimensions, right? In fact, all of our screens work in 2 dimensions. So it's easy to visualize a 2-dimensional array, but if you give another list within the list, see, the array function will accept as input one list. right? Within which you have given this another list which says that, okay, you're giving a row and another list saying that this is the third dimension. So if I do this 1, 2, right? And if I give another 3, 4, then this becomes my one dimensional, this becomes a three-dimensional array. However, it would be very difficult for even me to visualize or help you visualize how this thing is going to look. Does that make sense? Does that answer your question? Hopefully.
Yeah, but the same way, how about shape of A, like one-dimensional one? What would be the output? Just show me once.
Yes.
Yeah, 3 comma, it's shown.
Let me assign this to C, and the moment you see C dot shape, you will see that it will give 3 dimensions, right? See, if you see your one-dimensional array gives you the shape in a single number. Your two-dimensional array will give you shape in 2 numbers. Your three-dimensional array will give you the shape in 3 numbers. This is your X, Y, and Z axis. See, every dimension, here dimension as I mentioned means towards what axis? If you draw an imaginary axis, where will this number go? If you draw an imaginary axis for A dot shape, it says that it's going 3 rows. That means it's going towards the Y direction, the Y axis. You talk about two-dimensional, it says that on the x-axis there are 2, on the y-axis there are 3, and so on. Right? Similarly, this is x, y, and z axis. If you add more internal brackets, you will get 4 numbers. You can create more 4 dimensions, 5 dimensions, and so on. But if you print C, it will still print in your two-dimensional format. It's saying that this is your first row and this is the z-axis as well. Your x and z are combined together, and visualizing it becomes slightly difficult. Does that answer your question? Actually, this is a good question. Everyone, did you get an idea? The shape will give you the number of dimensions along with 2 rows, 2 columns. And what is 2? Because we do not have a third dimension in our 2-dimensional screens. We don't know what this is, right? This is your third dimension. You can create any dimensional or any number of dimensions. However, what will happen, classes? Most of us will always deal. Most of us will always deal in two-dimensional arrays at the max, because in future you will be dealing with tabular data where you have rows and columns, right? You will not have anything else apart from rows and columns. All of your data will be stored either in a tabular structure, even if it's in a non-structured format. It's dumped in case of images and videos. Even then, you will be converting them into binary formats and converting them into a two-dimensional data set. That is why most of our theory today will be focused on two-dimensional, 2 or 1-dimensional.
Ankit, I missed. Like first two represents row, and second row, second two represents column, and third one. Hello.
Class, am I audible or am I breaking down in between?
No, it's fine. No, it's fine.
Right? Okay. So see, it tells you the number of elements that you have along different axes. So now, generally, when we deal with any kind of data in any system, right, we always have two-dimensional data. So we can say we have rows and columns. The third two here is the number of elements that you have across the z-axis. But generally, we do not have any third dimension when we talk about data set. Is that right? If you have an image or a video, you even convert it into a tabular structure. Most of your data sets, structured or unstructured, will be finally inserted into something called as a tabular structure. You will have rows and columns. So that is where this is across the z-axis, but it does not have a specific. Okay, so with that, let me know, class, if you have any other question. See, let's make the session as interactive as possible. You have any question you want to ask, you can unmute yourself and ask. If you have a question, you can put it in the chat. If you want any more example, you can put it in the chat, but do ask. Okay, this is for you. So you, until unless you are clear, we should not be moving. Okay, so I move ahead assuming that everything is clear to everyone. Now, what we are going to do is, if we are all good, let's begin with our first. We'll begin with the first numerical operation. What we are going to do is we are going to use a function called as np.sum. So np.sum, again and again, I will keep stressing that NumPy is not a package which is used solely for arrays. It is majorly used for arrays, but it does not mean you cannot use it for other objects as well. What I'm going to do, I'm going to start with a simple mathematical sum. I know that it can be done by the plus operator as well, but just to give you an example and to always help you remember that it does not only work on arrays, but it can work on any integer or numerical data type. So this is the first function that we will be looking at today. This is called as sum, and it can take as input, again, it will take as input a list of numbers. I can give any list of numbers, it will add all the values, and it will give me the return the sum of that particular list of, okay, it will return the sum of the elements in that particular list. But now what I'm going to do is, see, this is simple. This is something for which we already have a plus operator. Let's create two arrays. np.array, let me create one dimensional array 10, 20, 30. And then let me create b is equals to np.array. Let me create 40, 50, 60. So let me create 40, 80, and 100. Let me print a and let me print b for our reference. If you see, I have created two one-dimensional arrays, 10, 20, 30, and 40, 80, and 100. Now what I'm going to do is, I'm going to apply the function sum. Again, sum always takes as input the list. So now I will have to encapsulate it in a list. And I'm going to say that inside the list, take the arrays A and B. Sum is a function that will always take as input a list. You can directly provide a list of numbers that you want to add, or what you can do is you can provide the two names of the two arrays. Now let me tell you, see, it looks easy that, okay, we have 700 plus 300, right? You do have this, right? Now people may ask me to do this. What this functions, what are the advantages, and why I keep saying that always remember it's not just an array. You can add any number of values. See, a plus operator becomes very difficult because you will always have to insert a plus between two numbers and keep doing that. So I want to do this. I will have to write down 700 plus 300 plus 900 plus 100. On the other hand, the sum function can directly take as input the list of numbers that you want to add. So if you have thousands and thousands of numbers, imagine you have thousands of numbers or millions of numbers that you want to add. Using the plus operator will become slightly tedious. That is where this np.sum comes into picture. You can pass it all the numbers that you want to add as a list of numbers and get the output. Similarly here, what you can do is this. Now we are going to talk about two arrays. Okay, let's just talk about two arrays, A and B. These are two one-dimensional arrays, 10, 20, 30, 40, 80, 100. What I want to do is I want to add these two arrays. Now there are three ways in which you can add these two arrays. This is the beauty of addition now. We are delving into slight mathematics. It means that when I want to add two numbers, what does it mean? That the signs of both the numbers are positive. There is no confusion. The sign of both the numbers is positive. That is what addition means. So if I have 10, 20, 30, 40, 80, 100, I can apply my function sum, which will take as input list. This is mandatory. This is how the function sum has been written. It will take as input the sum, and it will take as input the list. And within that list, you can mention what are the name of your arrays. So when you directly apply sum, what do you get is it will add all the elements inside both the arrays. But this is something, let's say, you don't want. You don't want this particular output. Okay, let's say you want an output where you want to, let's say where you want to add 10 to 40, 20 to 80, or 30 to 100. This is something which you want to do. There is a possibility. See, when you're talking about arrays, it will depend upon what you want to add, right? You cannot say that, no, I don't want to add the entire elements. You will always, since the sum is positive, you would want to add anything. So in that case, what we'll do is, let me go to the whiteboard now. Let us go to the whiteboard to understand this is, I want everyone to pay attention. But now what I'm going to do, classes, I want everyone to pay attention. Okay. This is slightly tricky. So I want every one of you to follow me as I say 10, let's say 20 and 30. Okay. And I have here 40, 80, and I think we had used 100. So now what I'm going to say is whenever I want to perform the addition along what axis is the question. There's a parameter in the sum function called as axis. Now please note this is called as, now see, let me tell you different tutorials, different books, different authors, different developers use different understanding of the concept that I'm going to tell you. You take the understanding which you feel simple. I'm going to tell you the actual meaning. What I'm going to say is the axis. Now axis here indicates there's a parameter called as axis, which will indicate what across what axis do you want to perform the addition. See, you can perform the addition like this. You can simply say, I'm going to add 10 to 40, get the output as 50, 80 to 20, 70, and 100 to 130. So there is an addition that I have performed wherein I have added the corresponding elements. There is one more way that you can perform this addition, and that would be this, where I would add 10, 20, 30. This will give me what? 30 plus 30, 60. And 80, 40, 100. This will give me what? 80, 40, 120, 220. So see, there are two directions or two axes across which I can perform the addition. Now, if I want to perform, see, if I'm adding my 10, 20, 30 to the corresponding 40, 80, 100, I'm going to say that I am performing my addition across this axis. This axis is called as axis is equals to 0. So whenever I give axis equals to 0, it means what? It would take the row and add it to another row. It's as simple as that. It will add 10 to 40, 20 to 80, and 30 to 100. The corresponding elements of the rows are added to each other. So if I give axis equals to 0, I will get an output in the same axis, but with the corresponding elements added. Similar to this axis is called as axis is equals to 1. If I give axis is equals to 1, what will happen is the corresponding columns will be added to each other. So 10 will be added to 20, 20 will be added to 30, you get 60. 40 will be added to 80, and 80 will be added to 100. So basically what I'm doing, I'm adding 1040 to 2080, which is ultimately added to 30 and 100. So you get the output across the same axis. Let me repeat this once again. Okay. I'm going to write down the entire concept once again. So I have two arrays, 10, 20, 30, and I have something called as 40, 80, 100. This is my second array. Now there are two ways in which I can perform the addition. If I directly use np.sum and I say a comma b, it will add all the elements, right? It will add all the elements and give me the value. I think it gave somewhat 240, 220 plus 60, 280. So it will give me 280 as the output. Now I have an option wherein I can say np.sum and I will say you add the two elements inside this array, but I want you to perform the addition across the axis or along the axis 0. So what is my axis 0? My axis 0 means I want to perform the addition in this particular or along this particular axis. So what will it do? It will add the corresponding rows. 10, 20, 30 will be added to 40, 80, 100. Just remember, if you have to do axis 0, that means your output is going to be exactly along this axis. If you want to get the output along this axis, that means you will be adding 10 to 40, which will give you 50, 80, and you can get 130. Similarly, if you want to add along axis 0, that means you will also get the output along the same axis. That means you will be adding 10, 20, 30, which will give you 60. And this will give you 220. So basically, I'm saying if I do np.axis 0, I should get this output. If I do np.sum and where I pass this AB inside that list and give axis is equals to 1, what I should get is this particular output. So based on the axis, the addition will be, or the sum function will apply that sum or addition on the elements along the axis that you have mentioned. Okay, axis is equals to 0. That means you get the output along this axis. Simply add the values. Axis equals to 1. That means you need the output along this axis. That means you will be adding the corresponding 10 to 20, 20 to 30. You get 60, 40 to 80, 80 to 100. You get 220. Okay, if we are good, let's quickly try this out, class. Let's quickly try this out. Let me go back to the why is my screen not moving? Zoom is really slow today. Give me 1 second. It's still moving back to the original tab. Give me 1 second. It's Zoom is very slow today. Okay. So what we are going to do, class? I'm going to say np.sum, and let me do one thing. We have already printed A and B. Okay, we have already printed A and B. So let's say np.sum. Again, see, some function will always take as input.
Ankit, I'm unable to see your screen.
You are not able to see what does it showing?
It's a blank screen.
Black screen. Okay, let me reshare. 1 second. Give me a second. The Zoom is excessively slow today. Okay. Okay. Meanwhile, class, I would suggest that you try out. Do not wait. np.sum a comma b axis is equals to 0. np.sum a comma b axis is equals to 1. Try that out. Meanwhile, let me figure out what is happening with Zoom. And here it comes. All right. Are you able to see the screen now?
Yeah, able to see.
Okay, so np.sum axis is equals to 0 will give you along the axis np.sum. Let me add a comma b. Axis is equals to 1. Okay, something is not correct. Okay, it's getting executed. Cool. So when I see that you have executed a plus b, a minus b, that is perfectly correct. That is something which will be covered as a part of your linear algebra, right? Because you can Hello, people, can you hear me? If you
Yeah,
can
Ankit.
hear me. Yeah.
Yeah.
So what I'll do is, I think my system has just got hanged because of heavy Zoom issues. What we'll do is, class, anyways, it's 12:30. We'll take a quick break, okay, and we'll be back in another 15 minutes. Till then, I'll also restart my system so that we go ahead without any interruptions. Will that work?
Yeah, perfect. No problem.
Yeah. Yeah. Let's be back by 12:45, 12:50. Between 12:45 and 50, and we'll start exactly at 12. Okay. I'll have joined through my phone. I'll stay connected through my phone. Yeah. Hello, is everyone back from the break? Is everyone back from the break? Where is the chat? Let me use a different system. Okay, I see a couple of people are still to come back from the break. Let's give them 1 more minute and then we will start. We'll continue rather. Okay, let me quickly import. Meanwhile, people are joining, let them I'll quickly import and keep the code ready. So I've changed my system. I have faced some issue in my previous system. The Zoom was not working as expected. I've changed the system. Let's see, this should be working as expected. Now, where were we? We had created 2 arrays. I think everyone is good till access np.sum and access. Yes, I'm going to assume every one of us is good. Till that, let me quickly recreate the matrices 10, 20, and 30. And then we have B, which is and if I print A and B, we will have the same codes. Okay, so what did we see? We have seen at the sum function. What does it do? np.sum. If I give A comma B, it will simply add all the elements which are present in my array A and B. if I give np dot sum, again, if I give a comma b, and if I provide axis is equals to, axis is one of the parameters which can be given along with, so it will, the sum function takes as input a list of different arrays that you want to perform the addition on. And for both the arrays, you can give second parameter, which is axis, that will perform addition on a particular axis. So if I give axis equals to 0, you see along the axis 0, the addition will be performed. And when I do np dot sum, again a comma b, but this time I want to add along the axis 1. What it will do is, it will add along the axis 1, which is the vertical axis. It will add 10, 20, 30, 40, 80, 100 and give you the output. I think we all are done till this point. Is everyone done till this point? Great. So now what we are going to do is, see, in the beginning, when we started with the sum function, I would have mentioned that sum is a slightly tricky function because both all the numbers that you want to add have the same sign. But in case of subtraction, you see one has positive, one has negative. That means you need to add one value and you need to subtract one value from the added value. So that is why only for sum, only for the function sum, you have this axis. For rest of the functions, there is no concept of axis. See, initially sum also did not have axis. It was added later because a lot of developers wanted to perform addition along different axes. But now we are going to look at subtract. And what subtraction will do? Subtract is a direct function. It will not worry about axis because you cannot determine what is positive, what is negative. The subtraction has a different concept. It means that you subtract one number from the other. So you take as the function subtract, which will take as input two arrays. You can give that I want to subtract your, let's say, you want to subtract A from B, or rather this is B from A. So if you want to perform B minus A, what we will do, let's bring positive B minus A. That means you pass as input BA. This means you want to subtract A from B. So what that has given 40 minus 10, 80 minus 20, and 100 minus 30 has given you the output. See, in case of, let me repeat, in case of add, you will have an option of axis, but in case of subtract, subtract does not take as input a list. It will rather take the direct numbers that you want to subtract. It will always take two numbers. Okay. And it means that you want to subtract A from B. That means you want the output of B minus A. You can try it out on two numbers as well. Take any two numbers, 120, and it will give you 100 minus 20.
Ankit, in this case, B has a major, like compared to A array, B array has a larger values. So then we use B minus A. Agar it is, but sometimes we are not sure which one has more or which one is larger, which one is smaller. In that
No,
case,
so,
we'll
okay.
represent minus.
Yes. So let's think about the subtract function, not in terms of more or great. What is the objective that you want to achieve? Do you want B minus A? Then you will give the first parameter as B and second as A. Now, if you want to perform A minus B, right, this is just for our study purpose. That's why I wanted to have positive. But if you give A minus B, this is what you want to perform. Tomorrow, you don't know what you will be, right? So let's say A is your final price, B is your discounted price, right? Or that amount of discount that you want to give. So in that case, your objective would be to subtract. What will be your input? np dot subtract actual price, comma, the total discount. So subtract function, here the objective is that it will give you the output of A minus B or B minus A. The first array that you give is used as positive. The second array is subtracted from the first array. Does that answer your question?
Yeah, actually, I was about to add this question for this thing, but I thought it is like over it, like not right now. Later, I'll ask the question.
Okay, so okay, let me know whenever you that question counts. Don't worry. So people who are done with subtract, your multiply, divide, everything works in the same way. Can you try it out? Multiply, divide as well. they will work in a similar way as that of subtract. You will have the same function name np.multiply. So now what you want to multiply to what? The
But
multiply.
for multiplication, we need to consider as a condition, right? Number of rows in a first array and number of columns in a second array should be same like that, like
Okay.
matrix manipulation.
So to answer your question, Vinay, we are not doing matrix multiplication here. Here, the corresponding elements are getting multiplied to each other. The matrix multiplication that you're talking about uses a different function. That function is actually called as dot function, DOT, which you will study in linear algebra. Here, your addition, subtraction, multiplication, and division will perform the operation between the corresponding elements. So when I say corresponding elements, it means it will add 10, 40, it will subtract 40 from 10, it will multiply 10 into 40, it will divide 10 by 40. So these four functions are the functions that will add or multiply, divide, or in case subtract the corresponding elements. So let's say you have two different arrays in which you have, let's say you want to create a sum product. Right? You want to just multiply the two elements to each other. In that case, you will use multiply. However, the matrix multiplication that you are talking about is achieved by the same package Numpy, but the function name is called as dot. They call it as the dot product, and it gives you the same result as matrix multiplication.
Yeah, sorry, I got you right. I'm sorry. Thank you.
Got it. No need of sorries. No question is silly. All only answers can be silly, class. So do not worry. Ask any question that you have. If I don't have an answer, I will find the answer for you, but you don't have to worry. Similarly, go for np.divide. We say b comma a. And let me know if you have any observation with respect to division. I think even during normal division, we would have discussed. Division always gives you a floating point output. All right. So class, if you're done till this point, once you're done, let me know in the chat as well. But if you're not done, let me know that as well. We are going to look at some other functions. So let me create another array. Let me call that function as exponent. Let me call the function as exponent function. What I'm going to do, I'm going to create another array. Let me call it as C. C is equals to np dot array. Let me say 1, 2, 3, 4, 5. Okay. Can someone tell me what we are going to do is we are going to raise this entire array. Sometimes you might have a requirement where you would want to perform e raised to x over all your elements. So do we know what e raised to x is? It's an exponential function. Yes. It's an exponential function. Does anyone know what is the value of e? E is called as the Euler's number in the field of mathematics. Does anyone know what is the value of e? Anyone? E raised to x. I didn't get you.
Normally, e raised to 2 means 7.8.
Yes. So e raised to x, anyone knows? It's 2.71. Have you heard? E value is 2.71. Okay, no worries. So e raised to x is a function which is the exponential function. If you come from the background, so let me give you some interesting facts about the exponential function. If you come from the background of math, it's okay. If you don't understand, that's also okay. No worries. But exponential function, if you would have studied your integrations or logarithms, you would have integration and differentiation. You would remember something called as e raised to x, which exists. So e raised to, if you do something, so e raised to x is the inverse of log x. Rather, it's considered to be the inverse of log x. It means that 1 upon log x is e raised to x. You remember e raised to x, the integration and differentiation, both were e raised to x itself. E raised to ax used to be a into e raised to x and so on. So that is the same e raised to x that I'm talking about. In sometimes there might be cases wherein you would want to calculate e raised to x. Specifically, there are certain algorithms which work on exponential. If you talk about logistic regression, and don't get overwhelmed with class, okay? I'm just letting you know because NumPy has a lot of mathematical operations. I don't want to simply tell, okay, see, in very simple language, this is np into e raised to, this exp is the name of the function that will give you exponential function. If I execute this, what I get is that each and every value in the array has been raised to e. So this is e raised to 1. What it does is exponential function will give e raised to that all the elements which are present in your array. So it has given me e raised to 1. This is stands for e square. This stands for e cube. This stands for e raised to 4. This stands for e raised to 5. So basically on a function e raised to x, your x value is 1, 2, 3, 4, 5. So basically you have raised or you have applied the exponential function on all your elements inside that array. But let me tell you that this is simple. See, this is maths. E raised to x, where e stands for 2.71. And then if I want to calculate e square, if you know the value of e, now you can calculate e raised to anything. But where will this be used? There are algorithms, statistical models, which will use e raised to x extensively. One such algorithm is called as logistic regression. Don't get overwhelmed. You are all going to study these things in details. But I'm just giving you a peek into the future that yes, you might think right now that there is no use of these functions, but no, there are. So we have one function called as exponent, which can get you the values of e raised to all the values. And you can use the function called as exp, pass the name of the array, and it will give you e raised to all the values. Let's quickly try this out. Actually, before you try this out, let me create one more function so that you can try two functions in one go. Let me create an array np.array and let me add some values 121, 676, 729. Let me add 196 and let me add 4045. Okay, 25. Okay. And what I'm going to do, see, I am going to calculate the square root. So if I want to calculate square root of all the elements inside your array, you can use a function called add sqrt. Okay. And if you use sqrt and pass the array, what you get is the square root of all the functions, right? 4045 has not given me the perfect square. 44 into 5. This is 4025 is what I should have mentioned. Sorry. So it will give me a perfect square of, still not giving me a perfect square. 4 into 5, 2025 is what then I'll add. This should give me the perfect square root of 45. Okay. So And just in order to give you an example, I have used some I have used some square numbers. But yeah, you can take any number, and if you want to calculate the square root of all the elements inside your list, you can directly use the function called as sqrt, and this function will give you the square root of all the elements which are present. Do you want to quickly try this out, class? Do you want to quickly try this out? Try out both exponent and square root and let me know if you have any questions. Since we are performing mathematical operations, you will hear from time to time some interesting concepts which we would have definitely used in school. Done, done, great. Let's give 1 more minute for the rest of the class also to complete. Meanwhile, Vinay, if you are done, do you want to try out log? There's a function called as log as well, which will give you the logarithmic values. np.log, create any array, or you can try out on any of the existing arrays, try to get the values of log. So basically in the background, let me just speak and tell you that if you see, I would have mentioned that numerical Python Numpy is used to perform all numerical operations. You will have functions for the simplest operation and you will have function for the most complex operation possible. All the functions would be available. np.log a, that's right. Log 1, I try it on D as well. Try it out on a bigger because 1, 2, 3, 4, 5 will all give you almost similar values. Log 1000, I believe, is 3. Log 10 is 1, log 100 is 2. Try out on this on a range of numbers from, let's say, from 1 digit to 5 digits. Okay, people who are done, let me quickly give you the example of log. Let me create an array E and let me say np dot ay. Let me say 10, who's 1, we know, then 100 is 2. Let me give 500 in between, 1000, and let me give a random value. Okay, and if I do the np.log of E, you will see that I will get the values of different log values. Okay, now these log values are, you might have a question, people who are aware about log, you might have a question that what is this log to? Is this base to the base 10? Is it to the base E? So the natural logarithm or the natural log is generally is to the base E. So this is something which you have to the base E. There are different functions. Let me print, in fact, all a few functions. There are a lot of functions. The basic one is with base E. Let me put it here. And in fact, it becomes confusing, I feel. So let me add F as the name of the matrix to avoid the confusion. Let me add F here so that what I'm trying to say is natural log. So we all know that logs are based, different logarithms can be calculated on different bases. So if you do not mention any base by default, this log is to the base E. But let's say if you want, you have a specific requirement wherein you want to have, let's say to the base 10 or to base 100, or in that factor, if you want to have, there are base 2, there is base 10. So we have functions for both base 2 and base 10 as well, which is available. What we can do is we can use that function. Let me say log to the base 10. The name of the function is, I'm going to print it so that you get the output in one go. np dot log and 10 is what I'm going to say. And within this, I'm going to pass F. If you see the output, you get 122.63. And if I want, let's say, log to the base 2, the name of the function will again be print. Let me print this np.log. And I'm going to print log 2. And I'm going to print the output. So you see, based on the base, there are two functions. See, there are rather three functions of log. If you do not mention anything, it is log to the base E. If you want to calculate logarithm with the base 10, you can use log 10. If you want to use logarithm with base 2, you can use with the base 2. Okay. Now you might have a question where and when we would have this in future. See, if in future there is a requirement, you already know the functions. So when the requirement comes, and this requirement might come specifically in e-commerce industries, right? Logarithms and exponentials are used extensively in your e-commerce industries when you are designing a recommendation engine, or if you're designing a tool to identify which post has to be coming to the top, which post should be appearing at the end. All these are the functions of logarithm and exponentials. So if you get into that industry, you might have to use these extensively. If you go into the finance industry, you might want to use some descriptive statistics, which again you will study in future. But yes, based on different domains, different kinds of functionalities can come into picture. Let me know class once done. Let me know if you're done. I'm going to assume this is straightforward, so most of you should be done. If you are done, what I'm going to do is let's go to trigonometry. A lot of you might work on image analytics, or you're going to work on larger images. So let me give you an example. I think in the last year, I had done a project wherein we were working on identifying, is there going to be a disaster based on satellite images? So we had the data from real-time data from multiple satellite images, and we were trying to create a model in order to understand whether there's going to be a disaster, whether it's going to rain heavily, or is there going to be a famine where you do not have any rains, it's going to be a dry season. And basically what we were trying to predict is what is the amount of produce that will be agricultural produce that will be created. Right, so there are multiple factors into that project, but basically we were trying to analyze different satellite images, and that is where your trigonometry comes into picture a lot. Right. So if you get into image processing, maybe your trigo will come into picture. We have all trigonometrical functions. Any trigonometrical functions that you know are all available in NumPy. Let me start with the simple function, which was called as the sine function. Okay. Sine function, I'm going to say np dot sine. Now, does anyone remember what is sine 30? Does anyone remember what was sine 30? Anyone? Sine 60? Okay, sine. Go ahead, Vijay, go ahead. Go ahead, go ahead. Sine 60 or sine 30, anything. Let me say sine 30. Does anyone remember what was sine 30?
1 by root 2 or something like that.
1 by root 2? Okay. So sine 45 was 1 by root 2. We have sine 30. Okay.
Then
So
3
what
by
we are going to do is sine 30 is what we are going to calculate. But there is one issue with sine in programming. Your sine functions do not take degrees as input. What we learned in our childhood was sine 30, 60, 90. These were all degrees. The sine function in programming language takes as input radians. And how do we convert a degree into radian? We multiply by pi by 180. So I'm going to say 3.14 divided by 180. If I go and calculate this, I will get the output as 1 by 2, which is 0.5. Since I have used the approximate value of pi, we are getting a number which is close to 0.5. Similarly, if I look at cos, we do have cos. np dot cos, if I calculate cos value of 60, which is again 1 by 2, I will have to multiply this by 3.14 divided by 180, and what I get is the 0.5 value. You can calculate tan, you can calculate cot, sec, cosec, everything is available. There are multiple, all trigonometrical functions, in fact, are available in NumPy. You can try out all these numbers. You can try out sin, sine, 10, cos, anything, but all are available. There are even advanced functions, a10, hypot, cos h, 10h, which are available, but these are functions which might not be useful to you. But yeah, the important factor here is whenever you are using these trigonometric functions, always remember that NumPy functions or NumPy trigonometric functions take as input radians, not degrees. So if you get the data in degrees, you will have to multiply this by 3.14 divided by 180, which is pi by 180. In fact, I would strongly recommend to use the math.py package rather than using 3.14 to get the exact values. All right. So class, see, let us look at a couple of more functions. Let me create a new array. G is equals to np dot array. And let me say some numbers, 3.98, 4.96, let's say 51, then 89.02, then 89.02 is what I want to mention. So I'm using some floating point numbers. Okay. There's a reason. We are going to look at a function called as floor and seal. We're going to look at functions called as round. Three more functions that we are going to look at. 3.98, 4.52, 89.02, and let me say 101.5 is done, 9 is done, 0 is done. Let's say 2, 4. Okay. There are 4 values in my array. What I'm going to do is I'm going to quickly apply the first function, which is called as round. I'm going to say np.round. G. So round function, we all know how does the round function work, class? How does the round function work? If your value is greater than 0.5, it gets rounded to the upper side. If it's less than 0.5, it gets rounded to the lower side. So 3.98 gets rounded up to 4, 4.52 gets rounded up to 5, 89.02 got rounded up to 89, and 101, and so on. So now there is, okay, excuse me. So round function does what? It will round up the values to the closest positive integer based on whether your decimal point is 0.5 or whether your decimal point is less than 0.5. Similar to that, we have a function called as seal. Now, what does seal do? See, sometimes you might have a requirement that you don't want to round it on the basis of let's say you don't want to round it on the basis of, what is this? Yeah. On the basis of the decimal point. What you want to do is, let's say you have 3.98, 4.52, 89.02, and 101.24. You want all these decimal numbers to be rounded up to the max number. That is the next number. You want 3.98 irrespective of whether the decimal number is less than 0.5 or greater than 0.5. You want the rounding to be done on the higher side. That means 89.02 should also become 90. It should not become 89. 101.24 should become 102. 4.52 will automatically in rounding has become 5, but irrespective of the decimal point, you want the rounding to be done to the next minimum integer. In that case, there's a function called as seal that comes into picture. You can say np.seal, pass your value, and you will see that 4, 5, 90, and 102. It has rounded up to the next value. And if you want to bring it to the lower side, that means you do, irrespective of the decimal point, you want 3.98 to be converted to 3, 4.52 to be converted to 4, 89.02, and 101.24 will automatically be converted to the lower side. Then you have something called as floor. The seal and floor functions will always help you to round the decimal, round up your decimal numbers or floating point numbers based on if you want to round it up to the higher side, that is the next number, you can use seal. If you want the lower number or the previous number, you can always use floor. So round, floor, and seal are the 3 functions that will help you in rounding up your decimal point numbers. Let's quickly try this out as well, class. The 3 rounding functions. All right. So apart from that, now class, we are going to look at aggregate functions. I'm going to assume that every one of you is done. If not, let me know in the chat. But if done, then let's move on to the aggregate functions. So aggregate functions, let me quickly create a new array. Let me create an array. Let's call it as h is equals to np.array. And I'm going to have some values such as, let's say, let me have the values as 1, 2, 3, 4, 5. I'm going to ignore 6, and then I'm going to 7, 8, 9, 10, and 11. Okay. So I have 10 values going from 1 to 11. And let me print this for your reference. What we are going to do is we are going to look at some aggregate function. I think we have already looked at one. The first function that we looked was the sum function. We are again going to simply use print, let me say sum of, or let me say sum is equals to, and I'm going to use string concatenation, and I'll print str np dot sum. So this will print all the sum of all the elements which is present inside my array H. Okay. Similar to sum, what we have is we have a few other functions such as, let me say minimum value. So I'll use np.min and I'll pass my array, which will give me the minimum value. Similar to minimum value, we also have something called as max value. So let me add here maximum value. And I'm going to say max. It will give me the maximum value, which is present inside my array. Then we have some min, max. I can also calculate something called as the average value. Average is a mathematical term. In programming, I'm going to call it mean. So the name of the function itself is mean, and you can calculate the mean value, which is 6 here. Similar to mean, I have something called as median. If you do not know what median is, do not worry. I want to introduce you to this particular terminology because in future, when you will be calculating the mean, median, and mode, this is something which you will be already aware about, right? Median is nothing but the centermost value. If you sort your list or sort all the numbers in the ascending order and find the centermost value, that is called as median. Now there is one value which I will tell you, the next two values are going to be new to you, but I just want you to make a note of these two functions. When you study statistics in future, these two terms will be used a lot. You will have a detailed explanation and a detailed lecture on both these terms. But let's say if you want to find something called as correlation coefficient. Okay, this is a statistical term, correlation coefficient, and you will study about it, do not worry, but still I want to tell you that this is the function which will calculate the correlation coefficient, so that in future when you actually calculate, you don't have to think like how will we calculate programmatically. We have a package Numpy which has a function COORCOEF. You calculate it, you pass the array, and it will give you the correlation coefficient of that particular array. Okay. And similarly, what you can do is you can also have something called as standard deviation. See, these are very statistical terms. Do not worry if you do not know correlation coefficient and standard deviation. I'm just exposing you to the functions which will calculate these two things so that you don't have to worry in future about what is going on. STD, I think it's just STD. Let me check just STD. These are called as aggregate functions, which are used to calculate different aggregated values. You have some min, max, average, median, and then certain statistical concepts such as correlation coefficient and correlation coefficient and standard deviation. Let's quickly make a note of these two. I know that you might not be aware about correlation and standard deviation. Do not worry, something which is going to be taught to you in future. But I just want to expose to you that these are the functions which will be used to calculate the corresponding aggregate values. All right, I am assuming that we are done. If you have any questions, please feel free to ask any questions that you have. If not, then I will move ahead. Now, class, we are going to look at certain functions, or let me actually first begin with indexing today. We have already seen in the beginning of the session how to perform an indexing. Let me create quickly a two-dimensional array hi. Let me create something called as j. I'm going to create a two-dimensional array. Let's say 1, 2, 3. Then I have 4, 5, 6. Let me create a matrix or a two-dimensional array with 3 by 3 dimensions. Let's say the last row is 7, 8, 9. If I print this, you will see that I have a two-dimensional NP array 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have already seen that this shape, the shape of this array is 3 by 3. It means it has 3 rows and 3 columns. The row indexing starts with 0 and the column indexing also starts with 0. So you will have row 0, row 1, row 2, column 0, column 1 and column 2. To access any element, let's say if I want to access this element, I will have to use a syntax wherein I say two things. First, 2 square brackets will be required. The first square bracket is used to access the row and the second square bracket is used to access the column. So the first number that you see here is the row index. The second number that you see here is the column index. So you go to 0th row, you go to 0th column, the value that you get is 1. So J00 will give you 1. Similarly, if I do J0, 2. So J02, when you look at this, what is this? This is an array which is trying to access the row 0 and column 2. So in my row 0, my column 2 is what? 3. So I get the output as 3. So you can use this to access any element within your array. You want to quickly try it out? Quickly make a note. Also, let me know what will J2, 1 will give you back. I would want you to give me the answer of this question without actually executing it. You can put it in the chat. J21 will give you what value? You 8, that's perfectly right. Yes. J21 will give you 8, that's perfectly right. All right. Now, class, let's look at a couple of miscellaneous functions. The first function that we are going to look at is called as np.arange. I hope everyone remembers what a range function was. The range function that we would have used in our for loop when we were studying lists, we would have used for I in range 0 to 10, and we would have seen that we have a start value, we have a stop value, and we have a step. Similarly, in the Numpy package, there is a function called as arange, which works exactly same to the range function, except that range function can be directly used. The np.arange function, on the other hand, will create a NumPy array. It will create a range of values that will be stored inside a NumPy array. So if I give 0, 10, let's say 0.1 as well, and it accepts decimal numbers as well. If I do this, you will see that I have created a NumPy array from the value 0 up to the value 10. So your start value is 0, your stop value is 10, and you are doing an incremental step of 0.1. Your start value 0, stop value 10, and you're doing an incremental value of 0.1. So the difference between range and arange is a function which is present in the NumPy package, and it will create an output which is a NumPy array. Now, similar to np.arrange, let me quickly take you through a couple of more functions. There is a function called as np.zeros. Sometimes what will happen is you will have to create empty array, right? So let's say you want to create an empty two-dimensional array. So this will take as input the dimension of the array that you want to create. Let's say I want to create a 3 by 4. Please note this is not a square bracket, it's not a list, but rather a tuple. This is something which indicates the shape of the matrix. If you see when you try to print the shape, even in that case, you get the output in round brackets. So np.zeros takes as input the shape of the matrix that you want to create and creates an empty matrix. When I say empty matrix, it means that it will create a NumPy array with all values which are zeros. So this comes in handy when you want to create some array, and let's say you want to create an array called as 3, 4. In future, you want that array with the shape, but at the moment you want to simply assign it some values, some random values. So it's equivalent to saying x is equals to 0. Let's assign this value 0. In future, we will see what we need to do. Now, let's say in across this, let me assign this to an array called as z. Let's print z. And what I want to do is, let's say I want this value to have a particular number. Then you can assign the assignment of values in NumPy array can directly happen with the help of indexing. What you can do is you can say Z, I want to go to, so this is my row index. This is my row index 1. So I will say, let's go to row index 1 and I want to go to column index. Let's say I want the third value. So my column index is 2. And then I will say, go to this value and assign it a value. Let's say the most famous irrational number, which is 3.14. Then if I print Z, you will see that 3.14 has been assigned in the index location where your row index is 1 and your column index is 2. So three things that we have seen in the last couple of minutes. A range function, which is very similar to the range function. The only difference is it will create an NP array data type and it will give you back the NumPy array. Then you have a zeros function, which will create the array, a array of the dimension or the shape that you specify in the input and fill all the values with 0. And then you can simply assign any. So this is true for all arrays, not just this. You can change the value, update the values, assign any value to any element within the array by simply accessing that element using the indexing concept and assigning the value. Here again, if you remember, if we go back to our first class, this is an assignment operator. Your right-hand side will be executed first, and then it will go and assign it to the left-hand side. So 3.14 will be assigned to the index location 1, 2 in the array Z. Let me know, class, once you're done. Let me know once you're done. All right. So I'm going to assume that we are all done. So let me take you through two functions and then we will call it a day. The next two functions are with respect to array comparison. Okay. So now there are two ways in which you can compare two arrays. So let me first quickly create these arrays. Let me have a is equals to np dot array. And let me do one thing. So now I'm going to create a list. Even on the list, see, what did I tell you? If a list has all the elements as the same values, it can be considered as an array. But let's go ahead and create np.array to avoid any confusion. But you can create a list here as well, okay? So I'm going to create 1, 2, let me say 2 and 4. Then let me create b is equals to np.array. Let me create 2, 4, 4, for example. 2, 4, 4. And let me create c is equals to np dot array, and let me create 1, 2, 2, or let me say 1, 2, 4. So let me execute these. You see that I have a which has 1, 2, 4, b which has 2, 4, 4, and c which has 1, 2, 4. Now, if I want to perform element-wise comparison, that means that the comparison should give me the output after comparing each and every element. Then I can use a function called as np.array. Oh, let me say np.equal, and I can pass the two values a comma, let's say b. If you do np.equal a comma b, you see that the output that you get is in the form of each and every element compared to each other. You have 3 elements in a, you have 3 elements in b. I'm trying to compare, are the elements in a and b equal? It will give you an element-wise output, saying that the first element or element at index 0 are not same. The second element is not same, but the element which is present at the last index, which is index 2, the third element is same. So 4 and 4 got matched. So you got an element-wise output, right? Now, if you want to compare at an array level, you don't want to worry about whether your one element is same or 2 elements are same. You need that if are the entire arrays exactly same. In that case, you can use a function called as array equal. And you can say, let's say pass a comma c, and the output that you get will give you one value true, saying that is a and c, are they exactly equal or not? If all the elements are matching, you will get that the two arrays are equal. If there is a single element that is not matching, it will say that, okay, a and b are not equal. So you can perform two types of comparison. One is element-wise comparison, wherein you will get an output at an element level telling that is the first element same, is the second element same, is the third element same, and so on. Then you will get the output at an array level if you use a function called as array equal, which will give you if the two arrays are exactly equal or not. It will compare all the elements. If all the elements are exactly same, you get an output which is true. If there is a single element which is not same, you get an output which is false. Let's quickly try this out. Let's try this out, and I think we are exactly dot on time, so we can call it a day. If you are done and if you do not have any questions, feel free to drop off. But please make a note of these codes. In the next session, we will begin with why is NumPy so famous among all the developers. Great. Okay, I think if we have no more questions, then feel free to drop off. I hope you enjoyed today's session and you learned a lot. Thank you, everyone. Have a great week ahead.